Okay, this is lesson 14, our homework check. We had question number 1 here. The solution to 5 minus 3x is greater than 35 is either x is greater than negative 10 or negative 10 is greater than x. So in order to solve for that, to see which one of these statements is true, another way to write this particular part right here, where we don't have the x in front, is to see that we can also read this inequality the other way, where in terms of x, we have x is less than negative 10. So I'm going to write it that way. X is less than negative 10. So we want to know if it's greater than negative 10 or less than negative 10. So if you find it more comfortable, instead of reading backwards, you can just rewrite it. Pointy part is next to x, which means x is less. All right, so we're going to solve this inequality to find out which statement is true. So rewriting the problem, we have 5 minus 3x is greater than 35. Solving for x, we want to go furthest away from x on that same side as the 5. To undo a positive 5, because there's no sign in front, we're going to subtract 5 on both sides. We're going to line up that inequality just like we would line up an equal sign when we did equations. 5 and negative 5 are a zero pair. They cancel out, add up to 0. We are left with a negative 3x because we have that minus sign that we can't ignore. So we're going to have negative 3x is greater than, and then we calculate 35 minus 5 is 30. Okay, our next step to solving x is to divide both sides by that negative 3. And remember, when we divide by a negative or multiply by a negative, our inequality needs to switch direction. So we're going to write switch here. And some people call that flipping. All right, negative 3 divided by itself is 1. 1 times x is x. X is less than 30 divided by negative 3 is negative 10. So the correct answer is x is less than negative 10 because we worked it out. Okay, number 2, we have a word problem. The school band director determined from past experience that if they charge T dollars for a ticket to the concert, they can expect an attendance of 1,000 minus 50T. The director used this model to figure out that the ticket price needs to be $8 or greater in order for at least 600 to attend. Do you agree with that claim? Explain your reasoning. So the first thing I'd like to do is just kind of think about this math problem in terms of the expression they gave us. They said 1,000 minus 50T. And they're saying that T would be the ticket price. So what if it was exactly $8? What would that do to this expression? So 1,000 minus 50 times 8. And if you do 50 times 8, you're going to get 1,000 minus 400, which gives us exactly the 600. So 600 to attend for $8 or greater. Now, in order to think about $8 or greater, we would need to do 1,000 minus 50T is greater than or equal to the 600 because we want at least 600 people to attend or greater. So I need to see if I make that $9, if this will be true, if I'm going to get more people in attendance, or do I need to make the ticket price cheaper to get more attendance? So we can test that out. Okay, let's try $7 a ticket. Let's try $9 a ticket. So, and you can even just use your calculator. We can do 1,000 times the quantity, 50 times 9. Okay, so 1,000 minus 50 times the quantity 9, which we can use our parentheses for it. And our attendance would only be 550 people. Let's try 7. 1,000 minus 50 times $7 a ticket. All right, that's going to give me 650 people. So it seems like the ticket price for this to work, I would want to have the ticket price be cheaper. So this is no, we don't agree, because when we worked it out, we noticed that we have more people in attendance when the ticket price is less, which makes sense. If something is cheaper, more people are likely to go. Okay, question number 3. We have from Unit 6, Lesson 13. It says, which inequality is true when the value of x is -3? So what we're going to do is, in each of these inequalities, we are going to plug in the value of -3 for x and then see if we get a true statement. Practicing part A, we have the opposite of -3 minus 6. Is that less than -3.5? So again, I could do this by hand as well, or with my calculator. The opposite of -3 is 3 minus 6 is less than -3.5. 3 minus 6 is -3. Is that less than -3.5? This is false. Again, remembering on our number line, if this is 0 and this is -3, -3.5 is further to the left. So it should be this is less, not that. So that's a false statement. Looking at our next one, we have the opposite of -3, which is 3 minus 6. Is that greater than 3.5? Well, -3 is not greater than positive 3.5. So this is false as well. Okay, here we're going to have the opposite of -3, which is 3 minus 6 is greater than -3.5. -3 is greater than -3.5. This is true. So we are going to circle C. Looking at this one, -3 minus 6 is greater than -3.5. -3 minus 6 is -9. And -9 is definitely less than, not greater than -3.5. So this is false. So C is our correct answer there. Okay, let's go on to the next page here. In Lesson 6, Unit 6, Lesson 13, we had to graph the inequality on a number line. We have x is less than or equal to 5. So we locate 5, and we're going to have a closed circle at 5 because we have that equal sign. And x is less means we're shading to the left. So it can be that number and anything below it. Okay, for x is greater than 5 and 5 halves, we can do x is greater than 2 goes into 5 2 whole times for 4 and a half. So basically this is the same thing as x is less than 2 and a half. Looking at my number line, 2 and 3, so 2 and a half is right in the middle. It does not have an equal sign underneath, so we're going to have an open circle there at the 2 and a half. And x is less, so less means we're shading to the left. Okay, last math problem is looking back at our tape diagrams, and it says write 3 different equations that represent the tape diagram. So the most obvious one is we know that total is 40. So we have here 19 plus 1, 2, 3, 4, 5, 6, 7 x's equals 40. I could swap those two and do 7x plus 19 equals 40 for a different example. To get a third one, I'm going to have to probably do something with these numbers. We notice that 19 and 40 have that number in common. So I can subtract 19 from here and 19 from there. And I could say that 7x is equal to 40 minus 19. Because if I had 7 x's, I could do 40 minus the 19, and I would get this amount right here, which if you wanted to work it out, you could also say 7x is equal to, and 40 minus 19 is 21. So you could also have this other option here. But they only asked for 3. But if you wanted, these two would also work.